So today we're going to talk about exploratory data analysis for longitudinal data using STATA. So here's a quick overview of what we are going to talk about. First, we're going to look at how to load in a DTA file. We're going to look at some summary statistics and then plotting longitudinal data, since this is a common question I get in a lot of tutoring sessions. So to start off, we're going to open our STATA, and we will start by creating a brand new do file. Here it is. And I like to split my screen so that I can see both my results, my command line, and my code. So to start off, we're going to need some data. And I went to this website, hbiostats.org, to kind of give some credit to where I got the data set. It was obtained from this website courtesy of Vanderbilt University. So I just got this first data set here, and this is the abm.dta file. So I downloaded that data set and I put in my downloads. So I'm going to first start by making sure that everything is cleared, and I'm going to change my working directory. So I'm going to start off by putting my directory where my file is located. So I have it in my downloads folder. So I'm going to set that as my current directory. That way I can pull in my data automatically using the use function. And since the folder or the file is called abm.dta, as you see here, abm.dta, you can just load it in with the name without the extension. And that's how you use the use file, the use function. So here we have a bunch of variables, and for this video, I just want to look at, let's say, 3 variables. So I'll use this function called keep, where I want to keep the blood levels, I want to keep the sex variable, and this year variable. So that gets rid of every other variable in the data set. It only gives me these 3. So blood glucose, year of admission to the study. So if we click here in the little magnifying glass, we can see the year, sex, and the blood levels. Now, one of the first things you want to do when you kind of look at longitudinal data is take a look at the average across the different years of a specific outcome variable of interest. So in this case, if I am interested in this blood level, I would look first at some simple summary statistics like their average. So I would say tab stat blood glucose level, and then I can use the stat command and tell it to only return the mean and, let's say, the standard deviation and the median. And I want to do that across all the years. So as you can see, that gives me the average mean across all the years in the data set. They're the median, the 50th percentile, the standard deviations for that data set. Okay, so after this, another thing we might want to do is we would want to plot these averages, because we can see just looking at these summary statistics, we can see that the values of these averages begin to slowly increase, kind of peak around 145.8, and then they start to slowly decrease back down. So this would constitute a somewhat of a quadratic trend. So we would want to verify that visually. So how do we do these visual plots? Well, we can use a two-way connected function to plot, but first we have to create these variables. We got to basically save these variables into a new column. And so how do we do that? We would say by sort year. So this is going to do a specific function, or is going to apply this function after this year to every single one of these years. So I'm going to say egen, which means I'm going to generate a new variable using an equation. So egen, meaning I'm going to generate a new variable with an equation, meaning the mean function. So that's an equation. And I'm going to take the average blood glucose level across all years and generate that as my mean, and my variable is going to be called blood mean. So if I run that, you see it runs well. Now look back at my data. Now I have a blood mean variable where for those in year 68, we have the average, the same average blood level. And similarly for 69 and so on. So now that we have that, we can now use the two-way function to plot a connected graph. So I'm going to say connected blood mean. So whatever goes on the y-axis is going to go first. And then what's going to go on the x-axis is going to be second. So I'm going to say blood and year. So if I do this, it's simply going to return the averages, a connected graph, where the circles are the averages across those time points. Now, notice how these time points are pretty spread out. So I might want to make finer adjustments to the axis. And I can do that using the X label command. So if I say comma X label, and I see that I want to go from, let's say, from 65 or even 67 to, let's say, 81. So I would say 67, 1, 81. So this is saying go from 67 up to 81 in increments of 1. So if you see that, now we have a finer x-axis, and we can see exactly kind of where these means are corresponding to. And we do still see, just like in the summary statistics, we do see the somewhat kind of a quadratic trend where it keeps going up, and then after a certain year starts to go down. So that's something to keep in mind as part of your exploratory data analysis. Now, how do we improve the graph? So here we see that our y-axis has the actual name of the variable, however it was named in the table. However, year has this label that was given to it already in the data set. So what we can do is we can give this variable blood mean a label. So we see label one of our variables, and that variable is going to be blood underscore mean. And what's the label we want to give it? We would say something like average blood level. And then we can say the units mg over dl. And that is going to give it a label up here. And if I run that same line, now I see that my x-axis improved and changed to what the label that I give it. Now, another way of doing this is we can just add a title. So let's say we didn't have this code here, and I had and I wanted to update the title on the y-axis, or the label on the y-axis. I would say y title, and I can give it a new name, blood, a new label. Let's say blood level. Let's say I want to simplify it. So now I see blood level. But now let's say I wanted to make this a lot bigger. So I can say comma size and then large. So this can make my labels a lot bigger. And similarly, if I wanted to increase the x-axis, I would do something similar, and I would say space x title. Here you do have to kind of relabel it so you can increase the size. So you would say something like year of admission. I can keep it the same, but then I would say comma size large. That way, both my x-axis and my y-axis labels become larger. Now, one thing to note is be careful here that you always want your plot to be one continuous line. So you see here, you have this little arrow down here. This is telling you that you're going on to the next line, but it's still considered as part of line 18. You're technically not on line 19. So if you did want to do that, if you did want to start a new line because you didn't want to cram everything, let's say right here, you didn't want to cram everything after X label, you can do that. You would say /3 times, or /3 times, and that then you can hit enter, and that puts you in a new line, and this should run well. Yep. So a lot of times, a mistake a lot of people make is that they don't put the 3 lines and they want to run this, and then they sometimes would get an error. See, command y title is unrecognized. So the first line ran, but it didn't read the second line. So you have to always put a space too. A lot of times, if you put 3 lines here and you try to run it, same thing, option not allowed. So you need to have this space. And then now you can run everything together. And now this treats it as if these 2 lines are one, even though they're on separate lines in your code. So now let's say you wanted to split the data into the 2 sexes and wanted to look at that plot and that data. So one of the issues here with this data, as you can see, you have the sex variable as male and female, but it's in blue, and usually strings are in yellow. So one thing you're gonna want to do is you're gonna want to update that to string, because this means that it is really taking on the label for that variable and not the actual value. So if you do describe, let's go back, if you want to describe that variable, that sex variable, you're going to see it's in long format, and this is the display format. So what we're going to do is we're just going to generate, first we're going to change it to a string. So we would say to string sex, comma, and then what are we going to do to that? We're going to generate a new variable, and we're going to call it sex cat. So sex categorical, because now it's going to be a string. So you see it ran well. And now we look over here and we see, so here we go. It's in red or yellow, but it's not blue. And so now these are strings. So we can update these strings to have the male and female string variables. So I would say replace. So I want to replace the sex categorical variable. I want to equal it to male. I want it to equal male if that variable cat, that variable sex cat is equal to the string 1. So if I run that, you see it changes. So that's how I know it ran well, because it changed over here. And then I want to do the same thing. I want to replace inside that sex cat variable. I want it to equal female if my variable actually had a string of 2. And see, we got that. Now notice how I couldn't do this with the sex variable, because this sex is really a label male. It's not really the string variable that it contains in that row. So if I were to want to do if sex equals 1, I should get an error. It would say type mismatch, because sex actually doesn't have a string. So that's why we needed to do this. So now let me double check, nothing changed. Okay, that's good. So now what I want to do is I want to generate another variable, just like I did here in the this egen part where I generated the mean for year. I want to do the same thing, but now I want to generate the mean for year and across sex, but sex, the categorical variable. And now I don't want to call it blood mean again, because that is already a variable that exists. So it would give me an error. Instead, I want to call it something else, blood mean sex, for example. Now, when I run that, I can look at my data again, and now across the males and years. So notice how here we have 77 for males, and in year 68, and here we have all the means for females. Year 69, it's 107, but for males at year 69, it's 122. So that's how we know that it worked. Now, finally, if we want to plot, again, we're going to use the two-way command, and we're going to, again, use a connected plot, and we're going to say blood means sex is going to be on the y-axis, year is going to be on the x-axis. But now I specifically want a plot if sex cat equals male. So this is going to ensure that we have only the plot for the male and not for the whole thing. Now I can repeat this plot with a space and say, okay, now I want that same thing, but for the female plot. And so if I run these 2 lines, I should get 2 plots like this. Now, again, we can improve our plots by updating the color. We can update the marker size. So these dots that get connected are the marker symbols. So let's say I wanted to make it a little better, less cluttered, I'm going to use these 3 forward slashes. And you see, we still run it. Everything was able to run. So now I can have it in 2 lines. But let's say I wanted my marker symbol. So I would say M symbol to change, M symbol. And let's say I wanted a plus sign. And then I also wanted a different pattern. So I would say L pattern. Let's say I wanted dashed pattern. And on top of that, let's say I wanted to change the color as well. I would say L color. So L color is green. So this is saying the marker symbol is going to change to a plus sign, but the lines that connect it are going to be dashed, and the color that connects, or the color of the line is going to be green. So here we go. So you see the plus symbol stayed blue, which was the original color we had. So if we want to change that too, we're going to say M color, meaning the marker color is going to be, I'll keep it the same. I also want it green. So there you go. I have the plus symbols in green, and you could also make these bigger using the, you can make the line thicker, L width. So line width, say I want it to be 1, a little bit bigger. And let's say I wanted the marker width to be a little bit bigger. So let's see well, first let's do the line width to see how it looks, how 1 looks. Okay, there you go. So the 1 makes it pretty thick. So you might want to decrease that to 0.5. There you go. And the marker width, say we can do 0.5. Okay, the marker width. Oh, it's M size. That's right. M size. So the size, I wanted to increase, let's say, to 2. But the width is for line. So M size is going to increase. So there you go. So now my plus symbol is a little bigger. So let's say I want it even bigger. So I would say 4. There you go. So you can change the marker size, marker color, line width, line type. And if you want to know kind of more on these lines, you can just Google connected. So you can say connected line options in STATA, and that's going to give you some more information here on the different connected patterns. So where is it? So you can say connected style here. Where is it? Here it says. So it says line pattern, line width, line color, and it gives you the different types of patterns you can use. So you have solid dash, dot, dash, dotted, short dashed, and so on and so forth. So you can really modify these lines however you want. And the last thing I kind of wanted to talk about was the adding a legend. So a lot of times when you do these exploratory data analysis, you want to kind of report it and show all the details you can. So on top of the lines and on top of the different markers you can use, you can also add a legend. So after the plots, so notice how this had parentheses inside of it, or had parentheses around everything related to that line. So this was for the female line, and these were for the male lines. And within that parentheses, we had a comma and the patterns and marker information. So now, but that was inside this parentheses. Once we want to add information to the graph, we have to put another comma outside of this, because now this is for the actual graph. So the legend information is going to go outside, just like the label information should go outside of that comma, after that comma. So now, say I want to add these labels here. Again, better labels. And let's say I wanted to improve these legends. Again, I'm going to give the legend better information because I don't like how this looks. I'm going to say space legend, and then I'm going to give it a label. So I'm going to say label, in parentheses, the first plot, the first line, label it male. And then you're going to put a space no comma, and then label the second plot female. So that's gonna label the legends. Here you go. So now this tells us that the green one is for males and the red one is for females. Now, again, you can update the titles. So let's say I wanted this X title and this Y title. I can just add that here. And boom, my titles are improved. And finally, you can also improve the legend information here by, I don't know, changing the order. So you want to put female first and then the male legend. So you would say order to 1. So that would put female first in your legend and then male second. And finally, you could improve the size as well by saying size. And then you would say times. Here, you're going to say times the number. So let me see if larger works. Does larger work? Or large. Let's see if that works. Oh, there you go. Yeah, so large does work. If it's too large, you can update that using the times 1 point, let's say 2. And that way, yeah, you can modify it to your liking. So that concludes the video. If you have any further questions about things like this, I would be more than happy to answer them. Feel free to send me an email. If there's a question that you are having trouble plotting, if you're having trouble understanding, and maybe some videos don't do a good job at explaining it, feel free to send me a message, and we can kind of cover that in the next video or in a later video. The next video I'm going to talk about is how to run some analyses on longitudinal type of data. Now we're actually going to be modeling the data. So that's going to be in the next video.